students, I'm Shobha, Science Faculty from Mangala Vidya Mandira. Today, let us learn the 11th chapter in our science, that is work and energy. Let us see these examples given here. A horse pulling a cart will do work. A man climbing the stairs is said to do work. An engine of a moving vehicle is also said to do some work. An object which is thrown up from the earth, it tries to come back and fall on the earth because of the gravitational force. Then also we call that the work is done. Hence, we can define work is nothing but when a force applied on a body produces a motion in it, then we call that work is done. Or work is done in a moving object will be equal to the product of the force exerted on the body and the distance moved by the body in the direction of force. The same thing when work done in a body is equal to the product of the force exerted on that body to the displacement, either displacement or the distance. So we can write it as W is equal to F into S, where F is force and S is either distance or displacement. So it is a scalar quantity, students, where it depends only on the magnitude and not on the direction. And it can either be positive, negative or zero. Negative means it will be doing the work in the opposite direction to that of the applied force. And its SI unit is said to be joule. 1 joule is equal to Newton meter. That is, force is measured in Newton and the displacement is measured in meter. Let us now move to some more examples. For work to be done, as we have seen, force and displacement both are necessary. Out of this, any one is not there, then we can't expect the work to be done. For example, a person is holding a book in his hands in a stationary position and he is just having some force. He is not having any displacement. It is just force has been applied to hold that book. Then there is no work done. No displacement, no work done. Similarly, a person is pushing a rigid wall. He is applying force, but the rigid wall is not moving. It is no displacement. Hence, the work is not done. Some more examples where there is a zero work is like around the sun moving around the earth. There is also no work done. And whenever the satellite is being moving around the earth, that is also said to be not work done. That is because they are perpendicular in the direction. Similarly, whenever a ball is thrown vertically upwards and the work is done to by us is will be positive, whereas the work done by that of the ball will be negative because it will be in the opposite direction. That is called as negative for work done examples. And when a ball falls back, the work done by the gravitational force is positive since it is acting along the direction of the ball. So in reference point, whenever we give a reference point and we refer, for us it will be in one sense and for the others it will be in the other sense. Our positive and negative differs in that way. Let us move to the next concept, that is energy. Energy, when we ask you to define, you will usually tell it is an capacity to do work or the ability to do work. Or scientifically, the amount of energy possessed by a body is equal to the amount of work it can do whenever its energy is released. This is a scientific definition of energy. So, amount of energy which is possessed by a body which is equal to the amount of work it can do whenever that energy is released is called as energy. And it is also again a scalar quantity which does not have depend upon direction, and its SI unit is joule. There are different forms of energy, students. Mechanical energy, heat energy, sound energy, electrical energy, nuclear energy, light energy, chemical energy, magnetic energy, many more energies. And in mechanical energy, you are mainly having potential energy and kinetic energy. So each forms are interconvertible. We can convert one form of energy into another form of energy. So in this chapter we will mainly focus on potential energy and kinetic energy, two forms of mechanical energies. So potential energy, energy which has been possessed by a body because of its position or because of its change in the shape, is called as potential energy. So whenever the body is at rest, or whenever the body is possessing energy because of its change in the shape or change in the motion or position, that type of energy is called as potential energy. For example, a raised hammer possesses some potential energy, means raised, it is having ability to hit something, so it is having some energy. Similarly, the water which is stored in an overhead tank possesses some potential energy. So as soon as it has been opened up, it will start flowing down at a great pressure and force. This shows it is having some energy. Similarly, a potential energy is stored in the compressed spring also. When a spring is compressed and kept, it is will be having some pressure and force, it will be created in that, and it will be bearing it. Once you release it, it jumps up and pops up. So this shows it is having some energy, so only it can pump up. Similarly, and potential energy is also stored in the stretched catapult, that is a game like you pull. So when it is stretched case, it will be having some energy. So that energy only makes that stone to hit something. So these are all the different types of energies which is possessed by the body because of its shape, size, and when because of its rest position. Coming to the kinetic energy part, kinetic energy is defined as energy of a body due to its motion. So whenever the body is under motion, then that body is said to have some particular type of energy called as kinetic energy. For example, a moving cricket ball, it possesses kinetic energy. Every moving parts in an engine or any machine parts will said to be having kinetic energy. Let us try to calculate the formula for kinetic energy. Potential energy, already we have calculated the formula in our lower classes. So in this year we are going to learn how to calculate the formula for kinetic energy. Hope you all remember what is the formula for kinetic energy. It is nothing but half mv square. So how do we get this formula? Suppose you consider a body which is moving with a velocity u, and it is having mass m, and it is being acted upon by a force F at the time interval of t. Let us consider this equation of motion, that is v square equals to u square plus half 2as. Okay, and we also know that work done by this object will be given by the formula F into S. What is F? That is force. S is displacement. We already know by Newton's second law of motion that F is equals to m into A. So substitute the F value as m into A. So W equals to m. We put A and S together, so that we are going to substitute that value. So according to the one of the equations of motion, we know v square equals to u square plus half u square plus 2as. So keep as one side and bring all the other terms to the right hand side. So you will get the as value as half into v square minus u square. Substitute this as value in that equation. W equals to m into as. So when we substitute, it becomes W equals to m into, instead of as, half v square minus u square. So this is the formula for the work done by the body when the body is in the kinetic energy, or forms possess kinetic energy. But when the body is initially at rest, then we can substitute u as 0. So anything which has been subtracted by 0 will be the same thing. So kinetic energy will be equal to, so W means work. Work is nothing but when we have energy only when we can do work. So we can replace W as kinetic energy equals to half mv squared. That is because u we have substituted as 0. So this is a formula for the kinetic energy. So again we'll come to a note. This kinetic energy is directly proportional to the mass of the body. When the mass is more, when the weight of the body is more, kinetic energy will be more, and when it is less, the kinetic energy will be less. It is also directly proportional to the square of the velocity of the body. The speed, the velocity will be directly proportional. Both will be increasing or decreasing together. If a mass is doubled, the kinetic energy also will be doubled, and the mass is halved, kinetic energy will be halved. Means it is directly proportional, na? Say same thing. So always kinetic energy will be positive. Why? Mass is always positive and velocity is always positive. So the kinetic energy which depends upon this mass and energy will be always positive. So kinetic energy is also once again a scalar quantity. It depends only upon the magnitude, not on the direction. So energy, it is expressed in joules only. The work done and energy both are expressed in the SI unit as joule. Let us move to the next concept. When we have work, it should be having energy. When both are there, there should be one term called as power. So what do you mean by power? It is defined as the rate of doing work in given time or consuming energy in a given time. So we can define as power is equals to work done by time taken, that is P equals to W by T. So instead of W, that is work done, we can also write it as energy consumed. So when you consume energy only, the work is said to be done. So P equals to W by T or P equals to E by T. This is a formula. All the formulas you should remember, students. So let us move to this power in detail. Power is once again a scalar quantity and its SI unit is watt. So it is expressed in watt. So usually power will be measured in kilowatts. So how many watts of power has been passed in 1 hour, that is a kilowatts. So commercially this energy will be expressed in terms of kilowatts only, that is 3.6 into 10 power 6 joules. That is a commercial way of expressing this power or energy. Transformation of energy. As we have discussed, there are different forms of energy: kinetic energy, mechanical energy, nuclear energy, thermal energy, solar energy, and many other forms. So we can convert one form of energy into another form of energy in different devices. I'll just go for 2 or 3. So when you go for filament bulb, here the electrical energy will be converted into light and heat energy. Similarly, in an electric iron box, the electrical energy will be converted into heat energy. So these are the different types of transitions. And in the case of loudspeaker, electrical energy is converted into sound energy. Gas stoves, the chemical energy is converted into heat and light energy. So these are the different types of transformation which happens from one type of energy to the another type. So lastly, coming to the law of conservation of energy, we all know this popular statement. Law of conservation of energy states that energy can neither be created nor be destroyed. We can't create any energy and we can't destroy energy. It can just circulate or move on from one part to another part. So whenever the changes energy changes from one form to another form, the total amount of energy always remain constant. However, wherever it may be moving, energy will be always the same. When a body is thrown upwards or dropped from an height, the total mechanical energy at every point in the path remains the same. This is because it is a sum total of all potential and kinetic energy. So this is another example. Potential energy is maximum and the kinetic energy is 0 at the extreme temperature. So potential maximum, this is just an to and fro motion of a metallic ball. So here when we start moving the ball from one end to another end, whenever it is on the extreme ends, it comes to stop for some time. So there the potential energy will be more and kinetic energy will be less. But at the time of traveling, kinetic energy will be more, potential energy will be less. So here we can see clearly the conservation of energy takes place. So today's activity, students, after going through this, you have many worked examples in the chapter relating to the formulas whatever we have discussed now. Just go and write all the example form problems in your project books. Thank you.